Phase changes. We've talked about the different states of matter. Another name for state of matter is a phase. So when I say phase changes, I'm talking about going from one state to the other. These changes are reversible. You don't have new substances, therefore they are physical changes. These will either be endothermic reactions, in which they absorb energy, and if it absorbs energy from you, you would say it feels cold. Or it is exothermic, which releases energy. If it's releasing to you, you would say it's hot. So an endothermic reaction would feel cold, an exothermic reaction would feel hot. First phase change is melting, which is solid to liquid, and this is where the average kinetic energy increases. So all the particles begin moving faster and faster. In order to melt something, it's going to have to gain energy from the environment, so we say it is exothermic. If you hold an ice cube in your hand, it's going to use the heat from your hand to melt the ice. Therefore, that's a clue that it is endothermic. The opposite of this, of course, is freezing, going from liquid to solid. This is where the kinetic energy decreases. Because it releases heat in the process, it is exothermic. If you're trying to freeze something with electronics, the freezer in your house, it's going to pump that heat out the back of the freezer or along the door at the base. We have what is called condensation, which is gas to a liquid, where you lose kinetic energy. So it is giving off heat to the environment. It is exothermic. When you set your cold glass down on the countertop, the moisture, the air in the room with the moisture in it, hits the glass, cools off, and the water that was a vapor gets left behind as a liquid. The opposite of that is vaporization. This is what you would call boiling. This is going from a liquid to a gas at the boiling point. Yeah, it's possible to go from liquid to gas below the boiling point. We'll get to that. You are increasing average kinetic energy, so it is absorbing energy from the environment. You have to put water on the stove to get it to boil. You have to give energy to it. So this is, that's why it's endothermic. There's a measurement that we call vapor pressure. This is where the gas particles will find themselves able to break free of the surface, but then they collide with the air molecules above those. Okay? One interesting thing is this picture right here helps explain hurricanes. When the wind blows, it's going to pick up and carry these particles with it. Those particles have a little bit more energy, so they get kicked all off up into the atmosphere and come down as rain. This is what fuels and drives hurricanes. If the water down here is hotter, then more water molecules would be able to leave the body, and now you've got a bigger hurricane. This is why we say that global warming is going to cause an increase in the number and strength of hurricanes. There's a famous example where a guy in the United States Senate, I cannot remember his name, he stood on the Senate floor with a snowball from outdoors and used that as an example to call global warming a hoax. He was the head of the Science and Technology Committee. That year, Washington, D.C. got a huge blizzard, and a bunch of people were saying, yeah, right, global warming, not true. It turns out that that snow was caused by global warming. The warmer temperature of the Atlantic just beforehand kicked more moisture up into the air, and when cold air overran it, during wintertime, it it caused all of that moisture to dump huge amounts of snow. It would have been far less snow if it weren't for global warming. We have evaporation, and this is where it goes from liquid to a gas below the boiling point. You know that you can set a glass of water out and it'll slowly evaporate because of what? Well, it's not even boiling. There's no heat, right? Actually, the heat is from the air in the room. Okay? What you end up with is occasional molecules get to leave the surface and escape. And eventually they all escape. That's when you say it is totally evaporated. We also have sublimation, which is going from a solid to a gas. This is also endothermic, but it skips the liquid phase. So right here I've got some dry ice. That's solid carbon dioxide, and it will sublimate, that's CO2, as gas. What I've done in that picture right there is I just simply have carbon dioxide and water, so the dry ice and water. So I put it in the water heats it up and causes it to sublimate faster, and then it picks up some of the water vapor along with it, which is what you see. Good fun. We also have deposition, which is from gas straight to a solid, and this also skips the liquid phase. It has to release energy to drop all the way down to a solid, so it is exothermic. Great example is the frost forming on your windows. In the south here, it might rain and then freeze when it hits the surface. That's called freezing rain. But here it's not liquid, it's just the moisture in the air as vapor that freezes to the surface. Alright, so this is one of those things that sounds really counterintuitive, but I'm going to talk you through it. Temperature does not change during phase changes. Temperature is the average kinetic energy of the molecules. So low temperature, they're moving slow, and a high temperature, they're moving fast. In order for this to happen, in order for the phase change to happen, we talk about the energy required as heat of fusion, which is the energy needed to go from solid to a liquid to melt ice, or heat of vaporization, which is the energy required to go from liquid to gas or to boiling. So this chart right here explains it. Now, this is an experimental thing. You can do it for yourself. You can heat up ice and see that the temperature rises, and then the temperature stops rising for a little bit. And if you look over at the glass, that's when it's melting. So in this space right here, there's a phase change. And this is where all the energy is going into breaking up bonds between the molecules. Then we have water, where we go through a temperature change again. And then when the water starts to try to break free of those bonds between those, they're called intermolecular bonds, then we go through another phase change. The temperature doesn't change. The heat, the energy from the fire, does not go into making molecules move faster, it goes into breaking bonds. So the temperature literally stays the same for a while, and then once it gets to steam, it gets hot again. The temperature starts going up. So one of the key things about phase changes is the temperature does not change. Now let me give you a real-world experience of that. This weekend, we had maybe a little bit of snow coming, and then they said, yeah, never mind. This is the time of year that we're going to start seeing snow in the next couple months. And with typical school day, you're saying, when is it going to freeze? Everybody's watching the temperature. And if you'll notice, a lot of times it's raining and the temperature's dropping and you're waiting, and the temperature drops really fast, and then all of a sudden it's like it stalls out at 32 degrees Fahrenheit or 0 Celsius if you're so inclined. And it seems to take forever for the water to freeze, and then it begins to freeze, and then pretty much at the same time, within minutes, all your friends from around the area are saying, hey, it's freezing over here. That's because the water is going through a phase change. So that means the area, all that water is trying to freeze, but it has to give up a huge amount of energy to do that before it finally freezes, and you got to wait for that to actually happen. Okay, now that you're finished with these notes, you just need to go over to OneNote and do the worksheet on these phase changes.